Ladies and gentlemen, welcome to the second year of AI Square for Digital Cities. My name is Rodas. On behalf of National Center for High Performance Computing, it is our honor to welcome you all to join the workshop. Before we start, just would like to remind you that after the session, please leave your comments in feedback section. You can find a link in the comment section. Thank you. Now we would like to invite Dr. Joseph Ortiz, Director General of NCHC, to give us an opening remark.
Hello, everyone. Good evening and good morning. Right? It's good to see everybody from different parts of the world. It's a new experience for me. Right? I think since early this year, we have tried like 4 or 5 different kinds of web conference, right? And now I actually have a chance to use Google Meetings. Thanks for Fangdang. I'm still trying to figure out all the gadgets, all right? I'd like to spend a few minutes talk about the digital transformation initiative there in Taiwan. Next slide, please, Fangdang. Okay, I think in Taiwan, I think some of you might know, Taiwan have a lot of small and medium business, right? So over the past years, right, the government actually pushing hard on computerize or digitize the small and medium business, right? Now we are moving forward, right? And we plan for basically the major project for the government in the next 5 to 10 years, right? Then we are actually moving with this direction. It's called Digital Transformation 2.0. So more than just small and medium business, right? We also include the major enterprise in Taiwan, also the cities, okay? Of course, on the city governments, we are talking about the smart government, right? Smart cities or intelligent cities project, right? But it's all wrapped in the digital transformation initiative that Taiwanese government is pushing forward. It's a multi-billion project, right, in the next 3 to 5 years. So our center, NCHC, is playing a major role, right, in this initiative. Last year, we have our AI supercomputer. Some of you might know it's called TWCC. The new name is the Taiwan AI Cloud, right? We make it available to both academic and industry users, and it was well received by the users. So this year, actually in this month, Pharma is leading the project called DAS project, right? Basically, we are making available big data analysis platform on the AI supercomputers, right? So people can use the tool and facilities to do all kinds of data analysis. Okay, and next slide. So this year, we're also building, we call the AIoT platforms, right? Especially for smart city project, right? You know, in the future cities, well, today's cities, we have a lot of sensors actually spread around different parts of the cities, right? Collecting the data from the sensors, right? Typically, we call it IoT, Internet of Things, okay? The data we collected, we can connect the data with the AI platforms that we have built today. So then this is the kind of a major project that we are building it. AIoT platform will be available probably early next year. Just like to share what's going on in NCHC with you. And later on, if you need some more detailed information, feel free to reach out to me and Fangdang, right? So that's all I have, and wish all of you have a successful conference today.
Thank you, Dr. Shi. Now we would like to invite Dr. Peter Asperger, founder of Pragma, to moderate the next session.
Well, thank you very much. I thank you very much for inviting me. It's a pleasure to see a lot of people that I know that even though we're physically distanced, we're still socially engaged. Although, Charlie, I agree with you. It'd be nice to have dinner together somewhere. And it's a real honor to be here in this second international meeting. I wanted to mention that NCHC has been a real contributor to the Pacific Rim application and grid middleware or Pragma activity ever since its inception in 2002. And have been involved with a lot of our international activities, both in the areas of ecology through the Global Lake Ecological Observatory Network, again with students at the undergraduate level, training a lot of them internationally, giving them a new perspective. They helped launch a really exciting initiative, the Southeast Asia International Joint Research and Training Program, that's brought a lot of Southeast Asia researchers into Taiwan to meet with a number of other people in Pragma. And of course, most recently, the Smart Cities activity that we're involved with today. So the third goal here today is to introduce a good friend and colleague of mine, David Corman. I've known David for the last 4 years. And when we were both working at NSF, he has a really unique background, both from an industry perspective, having been at Boeing as the chief scientist of Boeing's network and systems technology for research and technology. Before he moved to NSF, he is the chief program officer of the Cyber Physical Systems program at NSF. And he and I worked together on creating the Smart and Connected Communities program at NSF that he's going to tell you more about. In addition to that, he's been very involved with international activities, and I think he's going to say a little bit about that as well. In particular, in Asia, NSF and the Japan Science and Technology Agency have been working together to co-fund collaborations. So I really hope that maybe at the end of the meeting or by the end of the meeting or sometime afterwards that some of the ideas that we talk about might lead to collaborations, ideally at a time when we can really get together, but even before then, how we might begin to talk to each other. So with that, I know David has a lot of slides, and really this was just a welcome to David. So please, David.
Okay, thank you, Peter. Can you all hear me?
Yes.
Yes. Okay, great. Okay, so I will take over as presenter. And there it goes. A window. And
okay. It's coming.
It's coming.
That's there. It's there. So just.
Oh, it's there. Perfect. So you all can see it. Well, thank you.
It's not in presentation mode yet, David, but it is there.
So actually I have to change the display setting, I think. Okay, can you see it now? Or is it still in not display mode?
We can see it, but it's not in presentation mode.
That's very odd because it is on my machine.
It looks like it thinks that this is the presentation controller view. You have to swap your screens.
That's what I just had done. Let me try it again. Okay. Display, swap. That's still not it, right?
That's correct.
It doesn't seem to update. Doesn't like PowerPoint. Let me go to a short video that I believe you should see playing. So can you see the video or is it advancing? Doesn't look like it's advancing, does it?
No.
No, it's very strange.
Try resharing, David. Try to reshare.
Yeah.
And as a timekeeper, none of this counts against David's time.
Allow. Okay, so yeah, it's just showing the black screen. It's not like keeping up with. Let me try displaying the. That doesn't show anything.
No. Well, many of us can attest to the fact that the demo previous to the start of the meeting actually worked.
Right.
And so, as you know,
let me show screen 2. Allow. And I'm beginning.
Oh, good.
Okay.
You got
That's
it.
better. Okay. Well, once again, thank you. And let me start with a little video. And this is a video that we made at NSF. And the idea of this video is not to show NSF talking heads, although you'll see some of them. But what you'll really try to get a picture of is smart and connected community projects told from the perspective of the community people, both the community people and the researchers. So the first project that we're showing is something called Sonic, Sounds of New York City. It's a project done funded to New York University, and it is there to look at how do we utilize smart connected community technologies to reduce noise pollution in the city of New York. Another project that we have that really is a great example of really tight community engagement is a project that looks at how do you change the behavior of residents in low-income housings in response as they look to save energy. And part of the idea there is by saving energy, they're creating essentially a lottery. And the more that they save, the more the lottery increases and the residents get a chance to win the lottery prize. And the lottery is based on how much money is saved. Another one of our projects deals with stormwater management and control in Ann Arbor, looks at relationship between the University of Michigan, the city of Ann Arbor, and how they're able to reduce stormwater use, improve water quality, and have a significant cost savings. So let me stop the video, and Jim Carosi will probably excuse me for that, but tell you a little about National Science Foundation. So National Science Foundation funds roughly 85% of the research at universities in computer science. Our goal is to promote progress of science, national health, prosperity and welfare, and secure the national defense. When we created the Smart and Connected Communities program, we looked at trying to do something that's atypical of NSF. When one thinks of NSF, one thinks of things like looking for subatomic particles, looking for black holes. What we're really trying to do is show the value that fundamental research has in smart and connected communities. So it's research that isn't 20-year horizon, maybe 5-10-year horizon, but still has fundamental science and engineering impact. And what we want to show is that by asking the right questions, right research questions that span social and technical dimensions, we're able to work with communities, work and engage with communities in such a way that we can drive community impact and communities can shape the specific elements of science and technology that are part of the research. The idea here is similar to how our smartphones evolved. So smartphones and apps have had huge community impact. And at the same time, communities have really shaped the smartphone technologies, shaped the apps, and shape those capabilities. So we look at this as really a two-way impact between research and communities. In this chart, what I briefly wanted to show is that we do integrative research, so research that doesn't simply exist in the technology space, but also advances social, behavioral, and economic sciences. We work with a community, so one of the pillars of the Smart Connected Community program is having stellar community engagement. And that engagement includes research questions that are inspired by community needs. There's iteration between the community and the researchers and piloting of those solutions inside the community. One point though, and I'll get to this and towards the end of my talk, is it's still, the community has great impact, great influence on the integrative research, but to some degree it's still pushing of technology with the community working together. And we look for impact that is going to be near and long term. So these impacts might be 5 years, might be 3 years, but the point is that we're seeing impact not 20 years from now. One of the things that we do at NSF, and this emerged from our cyber physical system program, we like to look at what we relate as our flower diagram. And inside the center of circle, what you see are the core research areas that we fund in Smart Connected Community Program. Some of those are the usual areas in technology research, things like AI and machine learning, autonomy, security. And at the same time, we look at the various social sciences that really impact and help describe the behavior of individuals and communities as they react to technologies. So some of those include specifics on the economics, the sociology, psychology, education, and workforce. Around that circle, we have a band of community engagement. So that community engagement is between the research side and the core technologies. And around the outside are the petals, which are the different application spaces that our Smart and Connected Community program deals with. Those include things like agriculture, farming, transportation, mobility, energy, urban and rural planning. And one of the important points here is that, as you see, we do deal quite a bit with agriculture and rural areas. And that's actually one of the reasons why we started to think about this as not just a smart cities program. We wanted to really deal with communities of all sizes. So we deal with rural regions, small towns, mid-sized towns, and large metropolitan areas. Smart Connected Community Program officially kicked off in 2017, although it was built on a foundation of a set of programs, including the Cyber Physical Systems Program. And the Cyber Physical System Program created a number of the basic technologies that Smart and Connected Community Program is utilizing. We started 2017. We actually kicked it off with a set of workshops, a couple of those in DC, one of those at the University of Washington. We've run the program now called the Civic Innovation Challenge. And what the idea in Civic Innovation Challenge is that much as we would like, still the research in smart connected communities is very much academic driven. There's great community engagement, but the academic side is generally in charge. And what we wanted to do with Civic Innovation Challenge is flip that and essentially have co-creation of the research ideas between the universities and the communities So essentially an even deeper partnership. We've kicked off the Civic Innovation Challenge. There's an ongoing solicitation, which is due August 1st. And it really is an exciting program. I'll give you a few details in just a minute. This chart shows what we funded so far in Smart and Connected Community. The pie, around the pie, you just see, again, the application spaces, energy, mobility, and water management have been big areas in the first 2 years. That's actually going to look somewhat different once we introduce our 2019 awards. In all told, we funded $42 million worth of research in 2017, 2018. This year, we're actually doubling that amount. And the number of total awards is probably going to be around 50, but we're spending another 40 odd million this year in awards. Some of those awards have actually been made, and there's still a number to come. Smart Connected Communities is a program, and we recognize that communities are not just in the U.S., and that research doesn't necessarily stop at the country borders. And what we've done, as Peter alluded to, is spent a great deal of time first kicking off a collaboration with Japan Science and Technology Agency, and our current solicitation has provided a set of 6 planning grants jointly funded by the U.S. and Japan, and those deal with a variety of technology and social areas that are of interest to both U.S. and Japan. Each of these awards includes a researcher team from the Japan side, as well as a team from the U.S. side. We've also started with several awards in progress, a Dear Colleague letter that supports transition of research into cities through the Association of Southeast Asia Nations Partnership. And you will be seeing in the next, within the next month, a set of awards that look to transition research, some research funded by NSF into a variety of Southeast Asia countries, including Vietnam, Malaysia, and the Philippines. And we'd like you to stay tuned for future announcements on new collaborations that we're making. I mentioned Smart Connected are the Civic Innovation Challenge and its comparison with Smart and Connected Community. A couple things. It's co-creation of research concept with the community. It starts off with a set of planning grants, and it includes 2 tracks. First, 1 track on mobility, 1 track on resilience. It includes also co-sponsorship with Department of Energy and Department of Homeland Security. There's a planning grant phase of 4 months, followed by a stage 2 in which the winners of planning grants get to compete for a set of 12-month $1 million awards that we really look for really good things to come of that. And essentially at the end of the 12-month period, at the end of the stage 2, what we will be looking at is what kind of impact have we been able to have by accelerating the progress of research within the community and essentially creating this partnership. One of the things I would tell you is that interest in this is huge, and I've been practically every day I get 10 or more 20 phone calls and emails with questions about this. So just
David, that ringer was you got about a 5-minute left here.
Oh, okay. That's great. I've got about 4 minutes of charts. So just wanted to briefly discuss a couple of our smart connected community projects. This is one that you saw in the video. And the idea here was really, if you partner with affordable housing residents and bring in community engagement, so it's engagement with the Indiana Housing Commission, Purdue University, and a housing developer. The idea was, can you get residents to reduce their energy consumption through a set of incentives? And so these are incentives that include things like sharing the amount of reduction across the overall community. And the idea then was, what kind of technology, software advancements will actually enable success in in energy reduction? One of the ideas that they're using is pooling the amount of energy that is saved and making it a lottery for the residents of those communities. So the residents of the communities, typically low income, and we're not talking $1 million lotteries, but we're talking lotteries of several $100s in which your chances may be 10%, whereas in your regular lotteries, you're almost no chance. A stormwater project with University of Michigan, University of Tennessee, University of Virginia. The good thing about this is not only is it providing improved water quality, improved stormwater control, it's created startups, and it also has achieved a cost saving within the city of Ann Arbor in their water department of over $1 million, improved water quality by 30%, and they're in discussions with the city of Detroit on integrating this research, which could have hundreds of $millions in savings. There's a project that deals with trusting the quality of water that you drink. Part of the challenge here arose from the city of Flint, Michigan, which all of a sudden discovered that after some work on their water system, that there was lead and other metals in the water, and people want to be able to trust the water that they drink. So this is a project that is being that's being led by Virginia Tech, University of Florida, and North Carolina State, working with various water commissions in those areas. And it's essentially providing real-time information to water decision makers on the quality of water, providing information on contamination events, and along with that, what can you do to improve the quality? And that's it, and I'd be happy to entertain any questions.
Okay, thank you, David. And just with 30 seconds left. And for a lot of you, the last example that David showed is actually led by people that are well known to the Pragma community and Centra communities, Kaylin Carey and Renata Figueroa. So with that, are there questions? And I don't know, Pon, this is the first time I've used this technology as well. Are there little capabilities of raising hands, or does people sort of shout out? Pon?
Yeah, I think, is there any question from the floor? If not, maybe we move to the next one. So
may I ask a question?
Oh, yes, please.
Yeah, this is Felix. Davis, thank you for the presentation. So in your earlier slide, you show a balance between what I call the impact side and the technology side. So there's kind of blended in, which I think is a great goal. And in the project selection or formation, what do you advise us as academics? How do we actually balance between these two? Because there are certain important things about technology. For example, one of the projects is going to promote start a company, and there is a great amount of interest is about really helping the local community, like a Flint water and things. I just wonder any advice on how to balance these two.
So, in a program like this, what we really look for is that the research and the community really have established a partnership. And what we want to really see there is that, that it's not just research driving the community, but really a sense of, a sense of co-creation and enthusiasm that you can read in the proposal. What we, the challenges are really that all too often one sees just a technology push and the community being the recipient of the technology, but not being a partner. So I'll tell you one of the things that we get quite excited about is when at the academic side, you actually provide funding to the community. Funding so that the challenge is, how do you integrate research and make it real and make it work in the real world? And that doesn't just happen by throwing it over the fence. It happens by people from the community actually working with the technology, shaping it, and integrating it with the real systems that they have. And so, as from the researcher side, the challenge really is building those partnerships, which take time to develop. These aren't partnerships where you simply say, "Hey, can you collaborate with me in a proposal?" And when we can read that kind of collaboration and tell whether there really is something there or not. So it's really passion and a somewhat being able to tell us that there is more than just this is the first time you've ever worked with that community.
Thank you, David. I think probably Pong Pong would say the time is up. And so let me say thank you, David, very much. And Pong Pong, I give it back to you and thank you for the opportunity to hear this presentation.
Thank you.
Thank you. Now we would like to invite Dr. Joseph Ortiz to moderate the next session.
Joseph, you have to unmute.
Yeah, I clicked on the mic, but it did not obey. Hello, everyone. It's a pleasure to see everyone here and have a meeting, even if virtually, with colleagues and friends from Pragma as well as Centra. I'm here as the chair of the steering committee of Centra, and I'll be moderating a set of 4 talks. The speakers for these talks are actually old friends from Centra activities. Charlie is actually on the advisory board of Centra. Kathy gave an excellent webinar for Centra. Beth is a participant of central meetings from the beginning, and so is Felix. In the interest of saving time for the speakers, I'm going to move immediately to introduce our first speaker. That's Charlie Catlett. Charlie is a senior computer scientist at Argonne National Labs and a senior fellow of the Computer Institute. He's also directing the Urban Center for Computation and Data, and he has a long history of contributing to high-performance computing, grid computing, and cyber infrastructure in general. Again, in the interest of time, I'm not going to read all the achievements that Charlie has, and instead I'm going to give him the floor. And please, Charlie.
Thanks, Jose. You can just send the rest of the bio to my mom. She'll enjoy reading it. Let's see. Just remind me of time. You'll give me a 5-minute warning.
Yes, you have 20 minutes.
Okay. Let me make sure I know what time at 8:36. Okay. I want to talk about smart cities, but really about what we've been doing with the project called the Array of Things. And I'm not able to see the presentation. Are you able to see the slide?
Yes.
Okay. I think in general, what I've seen is the concept or the term of smart city tends to be overly driven by company product catalogs and technologies, with a kind of in some cases a naive belief that technology can solve problems that are fundamentally not technological. With the Array of Things project, we struck a partnership with a number of groups in the city of Chicago and a number of universities and researchers around. So I want to tell you the kind of backstory on what we did and why we were doing it and what the outcome has been. I have included a slide specifically for David because we ran into each other in the hall early in the project, and he said, make sure you go wrong in all the lessons learned. So I have just one slide with a number of lessons, each of which could probably be a 20-minute talk. Also mentioned, I've decided what I'm doing here with 2 screens is the Corman method. And I'm not sure why David was doing it, but I'm doing it because I don't trust my ISP. So I've got my phone here. So one of me can always be here giving the talk. Research into things related to cities. And the first thing that stood out to me, which was, I think common sense to them, is that cities are really not these big homogeneous blobs, but they're really collections of neighborhoods. And neighborhoods have character, they have culture, they have history, and they have unique challenges, whether it's life expectancy you see here, and you're really amazing differences from one neighborhood to another. These are all maps of Chicago, but maps of any city would look similar to this. You have a child that's born a mile to the west of the University of Chicago there, the white part on the left-hand side there, and their life expectancy is 12 years shorter. So, researchers we work with are asking, why do people age more quickly in some urban environments than other environments? Because this is the difference that exists even if you correct for things like racially specific disease or crime, which is something that cities like Chicago have. Then you can see asthma. Oftentimes these maps do look similar between, say, crime or health or access to healthy food and the population demographics in terms of income, for example. Asthma is one that's no respecter of income. There are things that are causing high rates of asthma in wealthy parts of the city. There are parts of the city that are struggling and yet don't have high rates of asthma. So what you see across the board looking at cities is, if you really want to understand what's going on, a regional approach or even a citywide approach to measurement isn't going to get you the resolution of data that you need. And so you need to look at strategies for higher spatial and temporal resolution, because some of the factors you want to look at also change hour to hour, not month to month or day to day. So, having seen this attribute of cities, we began thinking about how we might measure cities. Also about this time, we were involved. Chicago was one of the 100 Rockefeller 100 resilient cities. And I went in, this was about 2013, and I went into this workshop with about 100 people from across the city that the mayor's office put on. And I would have said before going into that meeting that sustainable, resilient cities are all about infrastructure and the environment, recovery from storms or earthquakes or other disasters. And it didn't really dawn on me until I was exposed to this, Arup did this framework, that an intelligent city, a resilient city, a sustainable city is a lot more than the infrastructure. It's about the planning and the leadership of the city. It's about the health of the residents, about the opportunities that they have. We, early on with the array of things, someone decided to say it was a Fitbit for the city or a fitness tracker for the city. I have a smart watch. I put the smart watch on and my IQ did not change. So something more than measuring the city is needed for the city to be smart. And so we began looking across these four general areas here and saying, well, what does a city like Chicago, what can we do to help a city like Chicago provide more opportunity or be a healthier city? And then we engaged the different research communities. Starting in 2013, we had about a half a dozen workshops with different science communities, asking them similar questions. And oftentimes I would maybe there'd be 20 people in the room or 30 transportation scientists, social and behavioral scientists, atmospheric scientists, environmental people. And we would say, we have the opportunity to put up a couple hundred gadgets around the city like Chicago. What would those gadgets do in order to help you answer the questions that you're trying to ask about urban environments? And those questions that community, we're seeing one slice in 2018 of the community here. By the way, Fong Pong is in this picture, proof that he's one of our collaborators. I can probably point him out there. Where are you, Fong Pong? There you are, right there, about eighth from the left. So what we heard from the city of Chicago, from residents, from community groups, and from scientists is a list of things they were interested in measuring. And then our job was to try to translate that into a strategy for measurement across the city. So each of those, or most of those, really translated into one of two kinds of measurements. The first of which is a traditional measurement with a sensor that takes some physical phenomenon and turns it into a voltage level or a current level, and you read that and you decide it's 37 degrees C or the noise level at this octave is a certain level. And then there were observations, which are things that they're difficult or maybe not even possible to measure. The simpler things that you might want to measure, like the flow of traffic, you can get statistics from the hoses that you string across the road, and you can say the number of people that turned right at this intersection over 24 hours, but you don't get a sense for the dynamics of an intersection. If you're interested in how people interact in public spaces, there's not a sensor for that. Even for things like flooding, it's not practical to put moisture sensors across the city when you can look at a camera and observe and then say there's flooding here. So these were one of the reasons, these observations were one of the reasons that we said we've got to have computing out at the edge for a couple of reasons that I'll go into later when I start talking a little more about AI at the edge and where we're going now, sort of post array of things. And you can see the device that we built there. We have a partnership with the city of Chicago that's grown to multiple departments and also to multiple companies. You can see the map there. That map doesn't really give you a good picture of, there are 130 devices up today. Some of them are original from 4 years ago. Many of them are in their second generation. What I could do if I were to pull up another slide is give you a color-coded map that says each of those groupings of devices are aimed at a specific science question or policy question that came from the science community, and in all of the cases corresponded with something that residents were interested in. You can see along the lakefront There's a bunch of them along that. You're looking at 18 or 20 miles there of lakefront. That's scientists that are interested in the lake effect on air quality and on weather. You can see a cluster of them on the south side here. I don't know if you can see my pointer on the south side. That is a neighborhood called Chatham. That's one of the more frequently flooded neighborhoods in the city of Chicago, which has quite a bit of flooding issues. Here you can kind of see a circle of devices on the northwest side there. That is Goose Island on the north branch of the Chicago River. And that's a place where the city is doing a number of different projects to revitalize that traditional manufacturing area to make it a place for information-specific jobs. So the city planners were interested in traffic in and out of that site. So we're like, great, we can put devices around that island. So every one of the devices has a story behind it, either as an individual, some of which were requested by residents, or from some science group that was interested in specific measurements. Irrespective of where the devices are or why they were put there, they all have roughly the same capabilities that I showed you on the previous slide. All of the data from these devices is transmitted every 30 seconds, all measurements from all of the sensors, back to the mothership, which is a secure system that is run by the University of Chicago on premises of Argonne National Lab. And all the data is free and open. I'm going to come back to some of these things in my brief lessons learned. The one exception to the open data are the camera images. There is no legal or ethical reason why we couldn't just publish all of the images, but we felt that that was going to be a non-starter with respect to partnering with the community. So we developed privacy policies in partnership with the community. And the privacy policies are that we analyze the images inside the device, what we found, the number of pedestrians, number of vehicles, if they're flooding or not. And then we do have, as part of our privacy policy, the ability to collect sample images. So we've built up a large library of images for training neural networks, but those are protected by, they're in a controlled system, and they're only accessible to researchers, any researcher that says, here's how we're going to use it, and signs a data use agreement. I talk about community partnerships. Here you can see a picture of our external advisory board. On this, you see several community organizers, several, actually, 3 current or former chief information officers for the city of Chicago, academics, president of the Art Institute of Chicago, the president of the Chicago Architecture Foundation. These folks bring a different perspective to the project, and they are involved in governance of the project, specifically accountability around privacy policy. I talked about the rule of 3. When I was talking about where the devices go, we decided that we would not put any device in any neighborhood unless 3 things were true. Number 1, something that we're measuring is of interest to the residents. Number 2, there's a science team that wants to look at the data and address or understand that thing that the residents are interested in. And number 3, there's somebody from local government who's also interested in that. It might be air quality, it might be traffic safety. So that rule of 3 has guided our deployment of devices and continues to do so. Now here's the slide. This is from the hallway conversation with you, David. Manufacturing at scale is really hard. I did not take any manufacturing courses as an undergraduate. It means that you're not anymore in control of the device. You have to turn it over to someone else and train them and give them all the tools they need to build it. Something every one of us know, water is the enemy of electronics. That's been one of our worst adversaries, is keeping water away from the electronics. Power on poles turns out to be pretty unreliable. I'm on a bi-weekly call with our Department of Transportation electricians who are responsible for the 300,000 LED lights that have been put in. And it's an issue every other week. It's like they're really concerned about how do they diagnose a power outage, and is it the pole or is it the feeder that's going to the pole? Residents want to be involved. a really big one is that partnerships are not MOUs. They're not agreements on paper. They're not lawyers getting agreement. They're really about people. And we felt early on, starting in 2013, that we needed to have real human partnerships with the different people working with us, and they've become sort of part of the project team. Even though we're not funding the electricians to put these things up, they feel that this is their project. Open data, I've already mentioned what we do. It's not enough to just publish it. It really needs to be legible, and there need to be tools there for different communities to make use of the data. You shouldn't have to be a machine learning expert to figure out what the air quality sensors are telling you. I've set this one apart, function before form. These devices, I constrained what the engineers had to work with by saying it's got to be a certain size, because I was worried it would be too big on the pole. And I can give you a whole talk on all of the cascading issues that caused for us because we were trying to squeeze so much into a small box. So function before form is really something we would do. I would say we would do different next time. Okay, what about edge? This notion of using AI at the edge. Here is the setup of the current AOT, Array of Things devices. Upward-facing camera, so we can look at cloud cover and things like that. Downward-facing, you can see a couple of examples of the field of view that we have about the size of a baseball diamond. With a new project, I'll mention Sage. We've revisited all of the design from top to bottom, and so our cameras now are panning and can look down the street rather than just down at an intersection. But here, for a couple of reasons, we do edge. One, it lets us do a really strong privacy policy. Number two, it saves us money on transmitting data. If you were having to send HD images, much less HD video, your data transmission gets very expensive. So, and number three, there are experiments where we want the devices to react in real time and not wait for the round trip back to the cloud to get an answer. So this notion of AI at the edge extends beyond just sensors to facilities and actuators and other things. And the idea is to push as much intelligence out to the edge as we can to reduce and compress data, but also to couple that together with high-performance computing models to improve those inference engines that are going out at the edge. I'm going to move a little more quickly because I think I'm running short on time here. Here's an example, and by the way, you can't really tell, but I did blank out the faces in here per our privacy policy. We've now started to look and see, can we detect the number of people that are wearing face masks? We've got a student working on that this summer as one of our COVID projects. Other things that people want to do with machine learning, computer vision at the edge range from flooding to cloud cover to water depth and even snow depth. And of course, the movement of people is something that's of particular interest to some of our behavioral science friends. Now, Array of Things is finishing up. It is now part of a project called SAGE. That's a mid-scale research infrastructure project as a independent observatory that is partnering with others, including NEON, to try to extend this AI at the edge concept into different settings than urban, into environmental ecological settings, but also into emergency management. Imagine, for example, that there's a wildfire somewhere northeast of Peter's office in Southern California, and there's a model that's telling the firefighters where that fire is going to go over the next 5 minutes based on data that's coming back or even code that's running out on Hans Werner Braun's Wi-Fi towers throughout Southern California. So the SAGE project is about moving out into these other environments with AI at the edge capabilities. You can see our leadership team there. I'm going to go quickly here. The idea here is this is the future environment. There are going to be billions of small devices, and there will be more and more very large HPC systems and everything in between. A 5G network has edge computing out on the towers. So how do you program this kind of environment? And moreover, how do you provide a programming environment that doesn't require machine learning and AI expertise that a biologist can use, that an environmental scientist can use. So the SAGE project is about exploring what is that computing environment that runs across this continuum, and how do we make it so that you don't have to, so that you could use a system like the Array of Things or NEON. You could program it as easily as you could program a supercomputer at one of the NSF centers. Let me close by just talking about one experiment in the behavioral and social sciences area. And with SAGE, we had proposed to put devices in multiple cities, and the ones with the red boxes around them, we actually have devices up in those cities. What we heard from social behavioral scientists is that they don't typically have a way to do repeatable experiments in different cities. A lot of what we know about poverty, for example, or crime is really boiled down to poverty in Chicago or crime in Harlem, because all the data comes from one city. So we have this notion of setting up a set of devices around common venues like parks or marketplaces in different cities around the world that would allow scientists like Mark Berman at UChicago to understand the interaction people have in those spaces. So I'm out of time. I'll just say thank you. I've actually taken sabbatical leave from Argonne and UChicago to be at a new institute called the Discovery Partners Institute that the University of Illinois is booting up in Chicago. So I'm still fully involved with Argonne and UChicago and building some new things with the University of Illinois. So thank you for letting me drop in and tell you about what we're doing.
Thank you, Charlie. We will have a discussion session after all the talks, so I'm going to skip the questions now, and I'm going to move on to our next speaker. She's Kathy Wu. She's the Gilbert Winslow Career Development Assistant Professor of Civil and Environmental Engineering at MIT. She is a star, even though she's very young. And she's working at the intersection of machine learning optimization and large-scale urban systems and other societal systems. So, Kathy, I'm going to let you move into your talk.
Okay. Can everyone hear me?
Yeah, I can hear you.
Perfect. Okay. Sorry, it took me a minute to figure out how to unmute myself. Well, thank you so much, Jose, for the very kind introduction, and to David and Charlie for the very interesting talks, and for Pong Pong for hosting this wonderful event. I'm actually really pleased to be back. I spoke at this for the first time last year, and so hopefully this will be a continuation for those of you who may have seen some of this from last year. So this is a really exciting time to be thinking and working about on transportation. We have anywhere from flying taxis to drones to platooning trucks to the Hyperloop to self-driving cars to electrified vehicles and everything. And they're really hard problems that are going into building this. We have a multi-trillion-dollar industry that's working hard on making some of these happen. And I'm excited about all of this as well. But actually what drives my research and what keeps me up at night is actually how do we actually get here? How do we actually get to these sort of beautiful, positive images that we envision the future of transportation to be? And to further motivate this, we can think back to say, this moment, but a decade ago or 2 decades ago, when we were first introducing some other piece of technology, we were looking at that bright future and what that might look like. And how does technology get introduced and integrated into our systems such that eventually they lead to this beautiful vision? And so if we look at a few examples, We have turn-by-turn navigation apps. This is, we can more or less view this as pervasive now. And we introduced this gradually at first. And actually, 10 years later, after this introduction, we realized that these systems were supposed to make our systems more efficient, but it's not actually clear if they are, and there are certainly many negative externalities, such as routing vehicles into neighborhoods and causing some safety issues. So similarly, with advanced driver assistance, for example, the Tesla Autopilot, we have deployed these systems. You can buy this piece of autonomy, but are these actually reliable or safe? We have already deployed these systems, but we aren't necessarily certain that they will be safe for all of us. Getting much more to the present day now, we are starting to see smart traffic systems, and these are also increasingly deployed, and we don't necessarily know if these systems are fair. And this actually really highlights the point that David was making about technology that we are still working hard to build as a piece of raw technology itself. But we also have not yet, we still have an opportunity to engage with the communities and to actually pave the path forward for that bright future. So what is that bright future? This may be preaching to the choir. Many of you will have seen this before, but self-driving cars are projected to dramatically decrease traffic accidents, reduce congestion, to help us a lot with our greenhouse gas emissions. And something that's notable and not discussed as much is access to mobility. Actually, about a third of the population in the US does not have access to mobility at this right now, or at least affordably. And that consists of 20% of the population that's either too young or too old to drive, as well as 10% of the population that has disabilities. So this is the bright future that we're trying to get to. And it's really informative to look at where we are now and what the space and time looks like in between. So if we just take one snapshot and look at US energy consumption, and the snapshot of today, transportation accounts for about 31%. And some recent studies from the national labs have actually indicated that in year 2050, which is the sort of placeholder date for full autonomy of self-driving cars, we actually don't know if the energy consumption will go up or down. And it's by a huge amount, by 100%, by a reduction of 40%. And why is that? There are a lot of complex factors. For instance, we could have these self-driving cars platoon, and that will save us some energy. They can drive more efficiently, that will save energy. There are a lot of different factors. And there's this culprit here, which is travel cost reduction, which is the largest potential cause of an increase of energy consumption. And this comes from new demand of transportation when the cost is reduced for, say, sitting in a car. So the question that is behind a lot of my work is, how do we manage this transition? How do we actually go from the 31% to this minus 40% in energy consumption rather than the plus 100%? What will that pathway look like, and how do we actually shape this trajectory? Okay, so that's a really big question. Let's break it down. What is guiding my research these days is we have these really powerful tools from machine learning that are being developed, and namely, I'm going to focus on deep reinforcement learning. And the guiding question in my work in recent years is actually, how can we use this tool, and how can it help aid us in analyzing the potential impact on traffic of automating a fraction of vehicles, focusing on a fraction because that is a transition point between having no autonomous vehicles right now and having 100% autonomous vehicles, say, in a few decades. And this is what we call mixed autonomy traffic. So what does this look like? For those of you who are not familiar, this will be a 1-minute introduction to deep reinforcement learning. It's basically a branch of machine learning that studies the interaction between an agent, and in this case, it would be the automated vehicle or automated vehicles, and their interaction with some environment. In this case, the non-automated vehicles, the infrastructure, the pedestrians, and so on and so forth. The automated vehicles or agent makes decisions in the system, and in our case, we're going to focus on vehicle accelerations and potentially tactical maneuvers such as lane changing. And there are a lot more kinds of decisions in transportation systems that this framework is suitable for addressing as well. And so what we're interested in is to learn a policy, often denoted PI in the literature, which maps some information from the environment into some action that the autonomous vehicle takes. So the agent is trying to actually maximize some reward, and in our case, we are interested in global rewards. How much can automated vehicles increase the average velocity of the whole system, mitigate energy consumption for the system? How can this be potentially traded off with travel time and safety and comfort? And so we're ultimately trying to optimize for some objective, and I wouldn't worry about this form. But the point is that we actually have a lot of recent developments in deep reinforcement learning that have shown dramatic milestone, groundbreaking results in the domain of video games and board games. And I'm sure many of you have come across these results before. And the question that we would like to tackle is actually whether these techniques are actually ready to help us gain some insights into societal systems. So as a brief overview of the results that actually I presented last time and also in the central webinar, what we can do now with off-the-shelf reinforcement learning methods is we can take these traffic Lego blocks is what we call them. So we isolate different traffic phenomenon, and we actually construct these environments that are specifically designed to analyze, say, traffic jams, analyze lane changing, analyze merging, analyze an intersection, analyze a bottleneck, sort of analyzing important pieces of the network. And we take a fraction of vehicles and swap them out for automated ones, so 5 to 10%. And then we actually run our reinforcement learning framework with off-the-shelf methods, and we see what happens. We'd like to assess the average velocity of the system and how much it changes. And we actually see dramatic changes. This has been very surprising to us, that off-the-shelf methods actually can demonstrate significant, so 30 to 140% increase in speeds of the system. And this is starting to tell us part of the story as to how automated vehicles can influence the systems that we are building as we introduce these vehicles into the system gradually, with just 5 to 10%. But this is really only part of the story. So let me revisit this environment piece. This environment piece, so what we actually use is we use an open source traffic microsimulator called Sumo. And these simulators are very nice. They are actually used to plan cities. They're among a really rich class of urban simulators that define the characteristics that simulate each individual vehicle in a system, which is microscopic in the grand scheme of the whole city. And so one of the basic behaviors of an individual vehicle is called car following. And this indicates how vehicles actually accelerate in response to the distance of the vehicle in front of it. So we use a very common model called the intelligent driver model. And it's really just a set of differential equations that we simulate. But this is actually only a small part of the simulator itself. So these driver models actually have to be coupled with a lot more complex behavior. So we have to make sure the cars don't crash into one another, and so we need some fail-safe logic. We need to incorporate merging, lane changing, different behavior near different parts of the infrastructure and near different vehicles. This all needs to be coupled with different road elements, the road network, signage, rules of the road, and whatnot. And the point that actually I want to convey in this slide is that the environment that we operate basically this environment is a very complex piece with all these different moving components. To actually say this in a different picture, no two cities are the same. So And actually, even if we zoom in, if we look at two different city blocks, they're also not the same. And so one of the challenges that we have, including the results that I showed in a few slides ago, is that right now what it takes for us to gain some insights into how automated vehicles will impact each network is that we actually have to, rerun our reinforcement learning algorithm. We have to train from scratch with every single environment that we see. So all of those Lego pieces, we train from scratch. But these environments are extremely complex, and it's basically not tenable to train from scratch for every single new network. So this really motivates what we've been looking at more recently, which is what we're calling transfer learning across networks. And the research question is, can knowledge actually be transferred across traffic scenarios? So for instance, if we have two scenarios, say this circular track and this grid network. We refer to transfer learning as the use of knowledge gained from a source task to actually bias the learning process on a target task towards a set of good hypotheses. So we might call this circular track a source task and this grid network a target task. What we'd like to do is gain some knowledge through running our reinforcement learning algorithm. And then we would actually like to transfer it directly to the task, and potentially we can, fine tune that knowledge from there, instead of having to start from scratch with this target task. And this can potentially avoid the sort of combinatorial number of possible environments that we see in traffic systems. So one more definition is a zero-shot transfer, and this is this extreme setting where no learning is actually done on the target task, and so there's no piece. We just learn in the first task, and then we actually see how it does in the second task. Okay. So how do we get started with this? We first actually look at scenarios where we actually expect transfer because the environments are really similar. So we actually consider this circular track to be our source task, and then we actually consider this circular track of different lengths to be our target task. So what this looks like is the x-axis is actually the vehicle density, or you can think of this as the circumference of this track. And we take the middle region of densities to be our training regime or our source tasks, and then the outside regions to be our test tasks or our target tasks. And on the y-axis, we actually see the average velocity with dynamical systems theory. We can actually quantify the upper and lower performance bounds. And we actually see that when we learn a controller, we not only match the optimal performance across the training regime, but we also actually match pretty closely to the optimal velocity in the target task. So, it may not be completely surprising that a policy that works in this in some density, some traffic densities also works in others. What is surprising to us is that the near optimality actually generalizes and is able to transfer as well. So from there, we actually move on to a more challenging scenario. One of the criticisms that we often see about studying the circular track is that there are no circular tracks that we care about in the real world. So we really want to move away from that, or at least move towards open networks. Okay, so that's what we're trying to do here. We're very curious about, okay, there is a lot of criticism about this closed loop circular track, but does it actually have some bearing to real world open network systems? And so this is a collaboration with Abudi at Berkeley, where we actually train on this closed network, and we actually directly transfer to this open network. And so the red is the so what we're actually seeing is the direct transfer result is actually the blue curve, and the black dotted line is actually human performance. And the red curve is actually the performance of training from scratch. So we can actually see that direct transfer from the closed loop to the open loop network actually already has us performing way above human driving performance. And then, of course, we can continue to fine tune that. Okay, so this is a really nice example of a successful direct transfer, and also gives us some indication that actually closed loop networks, despite the criticisms and also despite the sort of lack of resemblance to real systems, they actually can transfer to open networks that more closely resemble reality. So from there, we are interested in even more sophisticated regimes. So here's a traffic bottleneck that's really common in driving. I'm sure all of you have experienced getting stuck in a highway bottleneck, and it has this very interesting phenomenon called a capacity drop. And this is this phenomenon where if you look at the inflow versus outflow curves, as you increase the inflow into the system, you would expect the outflow to increase as well, and at some point you would expect it to flatten off at the capacity. But actually, the capacity drop indicates this phenomenon where actually the number of vehicles that can leave the system actually drops before flattening out. So we're interested in, well, if we had some fraction of vehicles automated, what would happen? Can we actually avoid this capacity drop? And so we actually do see this happening. The throughput goes up dramatically, and we actually are able to largely avoid that capacity drop. So now this again is training from scratch, but now we're interested in, if we take the policy that we trained here, what else can we use it for? And what we learn is that we can actually vary the percentage of autonomous vehicles without any retraining. So this is 10%, and we can actually vary this. Oh, sorry, got the order wrong. So we can actually change the network itself. We can actually double the number of lanes in the bottleneck from like 4 lanes to 8 lanes. We can actually increase the length of the bottleneck to have 4 segments instead of 3. And we can actually change the fraction of vehicles that are automated. So this we have really found to be remarkable. This is with no fine tuning at the end. And as sort of one last crazy finding that we found recently is we can actually take that same policy that we trained on the bottleneck, and we just threw it onto a grid network and just sort of saw what happened. And with no fine tuning whatsoever, we see a 26% improvement over the human baseline. And so in circle, I have this is a little bit complicated to look at, so I put a circle here so that you can sort of observe what's going on. So the vehicles are sort of platooning and sort of waiting until the next autonomous vehicle arrives, and then sort of switching off. So, and then I actually wanted to close with one last piece, which is that I've talked a lot about autonomous vehicles, but the same methodology has near-term application as well. And here I'm really excited that we've been able to partner with Fangpang and Shumi, and through NCHC, through a little project with MOST, with Taiwan City, and here's actually what we've been working hard on to put together, and we're very excited to actually start to look at these problems in the context of traffic signal optimization, because this has some really nice near-term implications. In particular, of course, we can improve travel times and congestion, but in the context of Taiwan, we're also very interested in the potential to mitigate air pollution, as well as to improve coordination across city boundaries where the traffic timings may be off. And so what's beautiful is that this is the same approach, but it has some potential for near-term benefits, even while the technology behind autonomous vehicles is being developed. So this is a sort of hot off the press results. And here we have the current controller here, and the sort of the reinforcement learn controller here. And one thing that you'll be able to observe is that the controllers, that the reinforcement learning based controller actually is able to learn a controller where the queues forming are actually a lot shorter than the ones in the current controller. So we're seeing roughly a 30% speed improvement and roughly a 30% queue reduction. And sort of in the next steps, we're very interested in, of course, studying this for more intersections, as well as a very interesting problem that is sort of more unique to Taiwan, which is the level of two-wheeled vehicles, these scooter vehicles that are very common in Taiwan. So I'm a little over, so I think I'll stop there and happy to take questions.
Okay. We're going to defer the questions to the end, to the discussion session as well. So we'll move on to the next speaker. It's Beth Blail. Beth Blail works in data governance, HPC, smart and connected communities, and she's the director of the Data to Insight Center. She's the Michael and Lori McRobbie Bicentennial Professor in Computer Engineering at the University of Indiana. And currently, she's ending an assignment at the National Science Foundation, where she's a science advisor and program officer. So, Beth?
Great. Thank you. And I appreciate it. Can people see my slides?
Yeah.
Great. Okay. So Fong Pong did I think as I realize now, just a really brilliant thing. He put me in charge of the discussion session, which I really do want to happen. So I am going to go through my slides quickly here so that we have some time at the end for discussion. This is, as Chose said, I am finishing up a 3-year term at the National Science Foundation. So this is a project that's a relatively new project, but I did want to take just a moment to talk to you about it and to just tie it to some of the work I'm doing in open science at the agency. So the work that we're doing here is motivated by the principles of open science, which goes back to 1942, an article by a person, Robert Merton, who said that openness and sharing of information are fundamental to the progress of science, both the progress of science and the effective functioning of the research enterprise. And the benefits are numerous, both in strengthening the overall scientific enterprise and reducing researcher burden, which is something we're taking on with this project. I just wanted to show you just really quickly. There's a 2019 United States Office of Science Technology Policy strategic plan on artificial intelligence. Came out last June, and it has a number of, it's identified a number of priorities. You can see up in the upper left-hand corner, including increasing overall long-term research investments in artificial intelligence. And then it identified areas where activity is needed, including human AI collaboration, safety and security, ethical, legal, and societal impacts, shared public data sets, and so on, standards and benchmarks, and so on, with a big emphasis on R&D, AI R&D workforce and public-private partnerships, which I should say also kind of flow into how the agency, the National Science Foundation, is interpreting its activity going forward. So our work is focused around shared public data sets with a little bit around standards and benchmarks. So there was a connection came out. People may be familiar with this. There was a solicitation that came out of DOE that made the connection between the fair data principles and the reuse of AI. Of products of AI or data as it feeds into AI. And basically from this solicitation, it says that, data and models, AI data and models can be made more reusable through attention to the fair data principles, and speaks to these principles. People may be familiar with them, proposed in 2016, and they were endorsed at the G20 meeting, the Hangzhou Summit in 2016. And there is in the context of GANs, generative adversarial networks, which are very quickly, they learn through attempts to trick the decision, So there's the generator, and the generator's on the left-hand side of that little diagram, and it is pushing fake data into the discriminator, and the discriminator is having to determine whether or not what it is looking at is real or fake, and the two working in an adversarial relationship tend to improve the results significantly overall. So the use case that we're looking at is if one uses a combination of sensor and simulation data, and in the course of monitoring an urban area, can you take that GAN model and all of its constituent pieces, including the data and proxy model or proxy simulations, and use that same model that performs well in one area, such as Orlando, Florida, and reuse that in San Diego. And so that's an example of reuse. If I can take this model that does a good job in detecting accidents or interruptions in one place, and then placing it in this other context, and how can applying the FAIR principles, how can we apply these in a way such that the reuse is increased? So the success overall is measured by an overall reduction in work in terms of the amount of work it takes to move this from one city to another, the level of interoperability of the resulting of the product itself that you're applying, and then its overall reusability. And again, this is the context of two things, both in reusing the model in a different setting, but also in replacing difficult to obtain data with a proxy, with simulation data. So there's a model that we've developed, and the model basically, describes the use in the middle of the diagram, but then it acknowledges that what comes into the model and what leaves the model are both fair as well. And this is where the whole overall the AI research infrastructure is enhanced by FAIR applied in multiple in both the uses and the production side of things. And then finally, and again, this is probably talking way too quickly, amazingly fast. One of the techniques that's underlying this that's of interest to us and draws on some of the work that I've done in Provenance is merging some of the work that's going on right now, and the National Science Foundation has a big push in its Convergence Accelerator activity. One of its thrusts is related to knowledge graphs, drawing off of some of the knowledge graph representation that your big companies such as Google have done very, very successfully. So can we have corresponding knowledge graph representation or knowledge network representations for science? So drawing off of that knowledge representation and what that can capture, some of this having a semantic web feel, can we combine that with the temporal aspects of that draws some from temporal graphs and some from provenance, where there's time-based weightings on certain states, and combining those two together. So in doing so, then one can capture when data morphs into a model representation. So at a different, it takes a different form at a different time. Can we represent that accurately with these time-based graphs? And then that provides the context against which this reuse and portability can be accomplished in lifting an Orlando-based model and trying to move it to San Diego. So that's the essence of it, drawing on again that AI can be enhanced through more attention to its products and the fairness of its products, and we are drawing on our provenance and graph-based techniques to prove that in a way that is measurable against the FAIR principles. So, and that is my final slide.
Thank you, Beth. Fantastically succinct, and that's good. So I will move to our last speaker, last but not least. Felix Wu is a professor of computer science and associate dean of academic personnel and research at UC Davis. And is interested in many things, including future internet design and integration with the social aspects of it. And he can explain it much better than I can. So, Felix.
Okay, can everybody see my slide?
Yep.
Okay, so thank you, Jose, and thank you for inviting me to join this section. So I'm going to, today I'm going to talk about an issue about information that touches many of the projects that are being presented earlier in this section. So this is what we have today. You'll probably recognize this picture. You can generalize to a lot of things. Basically, we talk about a data collection by the edge device. And we have some kind of cloud in the back. And of course, we can run edge AI to have some of the issue. But this is a dominating paradigm that we have today with a lot of application. And from this, I'm going to talk about some of the concern that I will be sharing about the technical solution. How do we actually address that? Oh, obviously, the first one is a privacy. And basically, today, for good reason or for not so good reason, a lot of corporate, they collect a lot of data. They basically collect as much as they can, and then they will figure out how to convert that into some sort of value. Maybe the value is helping their revenue. Maybe the value is helping the society become a better society. But in any cases, that this is actually touching on the privacy. And sometimes we got surprised by leaking out information. If you read the news recently, you will see a lot of things happening in different sectors about our industry right now. And this leads to the other thing is I mean, for example, GDPR was pushed a couple years ago, and it really strives for transparency and also to allow us to know as a user that how this information, what information being collected and how it's being used. So that is a trend that is already, we have some start, but it's the policies there, I would say the implementation is very loose. So I'm trying to make the screw tightening in this case for this one. And also, we talk about machine learning, and many of us probably realize that the machine learning has some fundamental issue. The machine learning will have a bias, and we just throw in a lot of data, and then it actually come up with recommendation, maybe work for most of the cases, but it has some kind of inherent bias that in there, while the system is actually driving our day-to-day life. And that's why the machine learning explainable AI is so important for us to hitting this issue. And also there is the adversarial machine learning. People try to attack, and which I'm not going to cover in this talk, but the other part of my life is looking at disinformation, and I can see that how social algorithm is being manipulated by the fake account, by billions of fake accounts that's actually trying to operate on that. So that's another issue that we need to deal with. But the last one, which is really my personal passion, this will concentrate a lot, is really the decision has touched people, has an ethical perspective. And how do we not just talk about this after the bad thing happens, say that's not ethical, that how do we be able to build in a control or transparency with the concept of ethics into the system that's actually data-centric. So that's kind of things I'm going to talk about. So I'm going to use an example that this is what I call personalized instant coupon, means that you go to a store and suddenly the AI technology in the store, in this example is Nugget Market that in my town, And it will actually recognize your intention of buying certain thing. And for purpose like a boost the sale, I might actually at that point send you something. So this concept about personalized instant coupon, it has two things. Is number one is instant. At the moment, it tries to hit you. And so it will have a great chance to be successful. And it's personalized because we want to not to target it like a traditional coupon sent to other people. We want to dive into your personal life, personal need, and be able to provide the things that you have. By the way, in the slide, you see the JSON here. This is essentially the first personalized instant coupon that we actually generate from our system. Okay, so this particular example, the first coupon is the product is actually a beer. All right. So whether the question I asked in my first slide is that should we actually issue the coupon? Should we actually means Nugget or means the system that actually really issue the coupon? Because this coupon is not just sending out a boost, but it changes life as well. Okay, so let's actually look at what's happened. Is that we have this idea that on the left, on the right, you can see that there's some interest about this person by the way he has eye contact with the camera or his face or his other record. We know that this person has some interest to this product. And assuming we actually generate a coupon, and that coupon maybe lead to a purchase of that product. So we have, from the system perspective, we have two questions that we would like to ask for at least transparency. Is that, well, how was the recommendation decided? It means that how did the system as a black box decide that this coupon can be issued to this person to actually to boost the sale? And also, the other information is also very important. I talk about privacy, is that I like to know, or at least the user holding the smartphone, he likes to know that what piece of information have been collected from him in order to make this particular decision. Okay, so now I want to say that now we bring in a little bit ethical perspective, is that there is some reason that you shouldn't issue this coupon. I mean, for example, if this person is just price sensitive and maybe issue a coupon to purchase some alcohol product, it's probably okay. But what happens if this person or one of the person in his family or close friend who have some addiction issue to alcohol? And in that case, you actually collect this information and decide, no, we cannot. I mean, if this person we really want to discourage, but at least what we can do is we shouldn't actually encourage him to do certain things. So in order to do this, if you look at these two questions, then now the picture is a little bit different because we need to access a lot of information. For example, the alcohol addiction information about the social network around this person, and for us to make that decision. And we can actually push off this. There is a lot of social value to this type of systems or cooperate. It's not just try to worry about their revenue, worry about their market, but they worry about a long-term relationship with their customer. And sometimes in management, there's a term called customer lifetime value. And this kind of ethic-driven, we can see that in the past few years for some of the negative instances, and we feel that this is really important to build up the customer and their trust with the service they're using. So this is our project that we actually started this project from just a year ago when I attend Centra in Jeju Island, and thank you for the Centra project for me to talk to many other colleagues and start this project called YSD, means the UC Davis. And essentially, we're focusing on two things, which I will talk mostly the first thing, but I will just briefly mention why the second thing is also important. So the first thing is about control and transparency regarding our information as the target that being captured by all the things around us. And we would like to also have the transparency to know how this information is being used, at least for my activity. So that's the first goal about how we're going to deal with. The second goal is really about policy, how about my info, maybe not raw information, it's derived information, including transfer learning. If it's authorized by me, that might be used for help activity of others. And both of this has a information propagation and control section. And both of them have an edge AI flavor. And both of them have a logic about ethic computing that we're going to build in. Okay, so the core technology we developed is called dual edge computing. So essentially, the previous picture I show is that we're the target, the edge collect the data, send it to the cloud. But we really think that it's actually two edge. One edge is the sensor. Maybe it's AOT, maybe it's whatever the sensor in the transportation system. But the other edge is yourself. That is ownership of the information. So basically what we're saying is that when we have two edges, they are going to negotiate, and they're going to negotiate what information that you're going to collect and how you're going to use it, and also mandate what information can be propagated up to the cloud. So that's basically the idea of edge computing. So let's actually go back to this picture that we have this the issue in coupon. So this is going to be this slide actually show our implementation for this particular application. Essentially, when the person decide they have an interest before they even get the coupon, there's one thing he need to commit is that where this particular product, in this case is a box of beer, is going to store. So basically, you can see there is that we are actually already, before you even purchase this product, we already know you should provide this information to see where this information is going to be stored. So that is the smart fridge at your home down there. And so essentially, we're doing a routing. This is in general a routing about food or any product from one fridge to the other. And in our system, we call it storage. Okay, storage is a general term about how things will be replaced. So basically, before you do anything, you can see that it's from the Nuggets fridge, and it will be transferred. If the transaction goes through, it's going to be your fridge. And the thing is that is a smart fridge at your home. It's actually keep tracking your local, but by the way, it's tracking always, but the information is following that dual edge computing. So it's nothing like you expose all your local data to the cloud, like a Google Cloud or whatever. So essentially, we know from this transaction, the historical interaction with the food, we actually know at least who actually access to this fridge in what behavior. So those basically let us know a set of people who actually related to the storage, which is going to be the destination for that beer. And based on this information, if you want to basically let the company decide whether you can issue a coupon, at this moment, some of the credential, I give just a very simple example, the credential about those people who have access to the fridge, they don't have any alcohol addiction problem, and that information at this moment is released to the local edge AI to analyze, decide, okay, that is a go, that then I can probably give you that particular coupon to rush. And a strong requirement for dual edge computing is that the purpose of doing this is exactly this. So after this is done, all the raw information is gone. I said some of the derived information might be used for other purpose, but the basic information is gone. So the information is just purely for the coupon. I will show you the next slide. You can see that how much information that's actually really when we build the ethic-aware logic. So on the right side, you can see we have from the interest all the way to smart home. And the thing is that we're actually cutting in the middle, have a two side. One side is the user side, one of the edge. The other is the sensor side, which is from the store. So we're really interacting. And interacting with the middle is what we call ethics-aware logic. It's actually to check first, they realize you have an interest, and then you're going to reveal information about the storage. And then you're going to reveal history about the fridge. And then you're actually going to explore the relationship among those people who share that. And eventually you have to provide the acceptable credential. And this logic will fit into the system, and the system will decide whether that's okay. So it's actually a balance between a boost of sale, and yet you have a control about here I'm using the alcohol addiction as an example for ethics, but you can see there is a lot of social science example. You can program that into some sort of social awareness logic or ethical awareness logic. Okay, so this is a computer. I think I'm running out of time. So I have to go a little faster. So essentially what we have is a edge computing, and then you're connecting with different edge devices. And the person on the left is the person who is actually going to collect, stitching the information. And the thing is that this 3-edge between Nuggets fridge and home fridge and the owner is going to communicate, and then to settle this down, and then to control that information related to both grocery shopping as well as the family information. And after it's done, it needs to be cleaned out to be handled that. Of course, one thing I actually didn't include to make things more complicated, there's other edges in this example, because there's other people, not just your family, but also say a Super Bowl party. There's your friends is coming, you allow them to access your fridge, and then that pattern of information, you need to have some consent and transparency in that process as well. Okay, using a ethical guardian that you can actually provide extra value and such that to provide this. Okay, so I'm going to skip this slide. So this is a project I was talking about, and I probably should skip the detail of the system, but the other application that we're developing based on this dual edge computing is for this, what I call environment tracking for coronavirus. Particularly, we're looking at a particular environment like a marketplace or like a church or like a school or like a shopping center, that what is the risk based on the sensory information being shared, being collecting, and then the same paradigm, there is a incentive, there is an ethical awareness consideration for us to actually help to solve this. Okay, so I just want to summarize my talk. So I'm really talking about the information related to support the AIoT or support the smart community or smart city. It's about information ownership, transparency, and the controllability. I'm focusing on how this decentralization of the information, but we can still put together to do exactly the same thing. I will argue that this model is actually better because this allows the end user be willing to share more information, such as my addictions information or addiction information, one of my family with his consent, and because I have a trust with the system. But more important that I like to drive, this is really my what I'm behind, is really try to do the ethics as a collaborative computational concept for our data-driven world. I mean, we have seen so many bad things happening that the information is being misused, that's being black box.
Are you there, Felix? We cannot hear you, Felix. Felix, are you there? I can assure you that the moderator did not shut up Felix.
It may have been the algorithm in the Google meetings.
Yes, I think
the organizers put in.
Oh, he's back. Are you okay, Felix? You've been a victim of the dual edge computing. We can't hear you.
You're
Felix.
muted, Felix.
Yeah, when did you lost me? I probably talked to myself for the past 25 minutes or something like that.
No, some ethical consideration here.
Okay, good. You got the right keyword.
You were wrapping up. You were in the very last slide.
Oh, okay. I'm sorry. I'll just do it very quickly. Sorry about that.
We're halfway through the last slide.
Yeah, I'm just saying that it's really there are so many things that I don't want to pinpoint which organization, but it's interesting that there's so many organizations. They're doing something, misuse our information, and we're part of it because we provide information for them. And also there's a lot of black box, as I mentioned. There's bias, and also there's a hidden relationship that we didn't know. I mean, we can talk 2 hours about what happened. And I also see a good trend in today's society that now they are cooperate, they want to opt out of certain sector of business that because of ethic concern. I mean, you can think how many companies decide not to do advertisement with Facebook. And IBM CEO, Arvind Krishna basically say their company is not going to do any technology advance in facial recognition. And I see a good thing from the business perspective. That's actually people are now aware. And because of the internet, because of the smart connected community, now they're facing pressure to deal with this. So that's why I just want to throw this as a direction for us to consider what we're doing in this community. I'm going to stop here.
Okay. Thank you, Felix. That concludes the set of talks that we had for this event. It's going to be followed by a discussion period. Beth will moderate that particular discussion period. But I'll be here and I'll ask questions. So,
and Beth, I think we can have 20 minutes. I talked to the conference organizers.
Great,
we can have
excellent.
20 minutes for discussions. Yeah.
Great, good, thank you. Good. So my thanks to all the speakers for their I think inspiring topics. And I think it's given us a significant range of issues to discuss. I'd like to go back to Peter's remarks in the beginning that there may be topics that we could carry into subsequent discussions and defined joint activity, which I think is exciting. Let me just start with a question. And as I'm doing that, I welcome the audience to weigh in with questions for the panelists as well. And I believe there's the chat mechanism. Use the chat mechanism. I think is probably the best means to do that to get our attention. But I will ask a question of the panelists, and this is a fairly evident one in the face of the global pandemic that we're facing right now. What do you see as a potential change in maybe urban dynamics or rural dynamics as it affects your engagement? And Charlie, this might be most suited to you to start, as it affects your engagement, your smart and connected community engagement in these settings. Do you see that being changed by the course of events that are taking place right now?
We thought, our interaction with at this stage of our project has been more with the city than with the community, just because we're going through and we actually thought this period would cause us to be able to get more done with the electricians because they would be less busy, but turns out that they're more busy. as far as our interaction with the city, I'd say this situation has really, across the board, not just with our team, but folks at all of the area universities in Chicago, even just tentative connections with the city have lit up because there's so many opportunities for science to work with the city on COVID-related things. For example, the Chicago Department of Public Health, I was on the phone with a person there and the city chief data officer a couple of weeks ago, and they said, we're used to dealing in the public health, we're used to dealing with either seasonal flu, which is high volume but predictable, or low volume, slow moving disease like AIDS, for example. And all of our methods are broken, and the city's given us these cloud systems we don't know how to use. So I reached out to UChicago, UIUC, and UIC people, University of Illinois at Chicago, and within a few days had about 18 different teams say, we want to help. And the city it was sort of like, be careful what you ask for, because we've now had to sort of regroup because we overwhelmed them. So I think what it's made us realize is that we need to think about how to quickly ramp up help like this for different parts of the of city government, and maybe, I mean, who could have predicted this? But I would say it's kind of back to my comment earlier about partnerships being about relationships. This started because the guy who's in charge of innovation for the public health department called me at home on a Saturday afternoon and said, can you help? And by Monday, we had a team put together.
Nice. David, you as in your position at NSF, do you have thoughts on how the smart and connected community responds or could respond to an anomaly such as this? Oh, you are muted, David. No, David, you're still muted.
Not that I unmuted.
There, gotcha.
Oh,
okay, you're on now.
Okay, so the COVID is really, one thing is we started our Civic Innovation Challenge with 2 tracks, resilience and mobility. And we started this something in like November, and COVID hit. And all of a sudden, the whole world has changed with what does resilience mean? And resilience really means, in part, how does one recover from all this? How does one deal with all the challenges? And what the pandemic has done is it's really spawned a whole new set of research challenges that are both from a technical perspective and from a social perspective. So to some degree, I would argue that it has magnified the challenges of smart and connected community, because now we're not simply talking about how can we improve the quality of life, but in part, really, how do we get back to where we used to be when we weren't so smart? And it's, I think, spawned just huge creativity among both the researchers and the community in terms of what they're willing to accept as research solutions.
Thank you for that. Any other comments?
I posted something on the chat.
I saw that, Jose. Yeah, let me, I will move on to that. Okay, so there is a, Jose Ortiz has posted something on the chat. I will read it, and it is to the entire panel. Bias in data and learning is an issue that is pervasive in all systems discussed today. Can you comment on manifestations in your systems and how you think it can be avoided? So bias in data and learning, how it manifests and how it can be avoided.
I can maybe comment on
this. You want to take a
this.
stab at that?
So, I mean, this will be a bit of a different type of bias than what is being discussed a lot in the media, in the sense that I don't even know the implications of the bias in the data. So I do a lot of work with traffic modeling, and the community has sort of overfit to a few very small data sets in this community. Namely, there's one data set called NGSIM, which is collected on a California highway. It's like 3 hours of data, or maybe it's 10 hours of data. Anyway, it's a very small amount of data. It's on one stretch of road, and a lot of the models out there for driving behavior is based on this set of data. There are a few other small sets of data that are out there that are used to model vehicles as well. And then these models are used in traffic simulators that are then used to plan cities. So you have this sort of, like, whatever bias is in that data, and there must be some bias because it's on one street in one state in one country, that will be propagated in downstream to all the decisions that it affects. I'm actually really excited about our collaboration with Pong Pong and NCHC, because we potentially through traffic camera data in Taiwan City in Taiwan, we can potentially counter this bias to some extent by having a lot more representative of data to begin with. So that's one place where I am very cognizant that there is certainly some bias in here. I don't know the effect. I don't even know, I cannot quantify it in any way, but I know that there is some.
So, okay, I like to respond to this a little bit. So I actually gave this talk right before the COVID-19 in February in Irvine. I spent 2 hours to talk about this. The example I study in depth is about the election, the presidential election in 2016. And the thing is that we specifically quantify to measure the effectiveness from the social algorithm. Basically, it's the AI algorithm from Facebook decide what information to deliver. And Fox News is actually a lot faster, a lot more effective compared to the left wing and the center. And the reason is very simple. Just an example is that because they're conservative. So conservatives are more get together around very few groups, such as Fox News. While the left side or center, they have a lot of group, but they have medium size. They're smaller size compared to Fox News. So if you think about AI algorithm, when I look at this, I don't know about left. AI algorithm doesn't know left side, right side. They don't know the journalism landscape. They actually see there's a big group called Fox News. So anytime there is something come out, all the people subscribe to this side, they actually will get it immediately. See that in the what we call the social algorithm, AI algorithm, they're actually learning, but they don't know why. They need to have a built-in more explainability or some sort of social science concept in the AI, because today's learning is basically, regardless what learning is, basically X and Y. You give it a pair of X and Y. What we need is X, how you're going to from X to Y, there is a middle point need to be built into the training process, and for them to avoid problem like this. Yeah, so there are so many examples about this kind of bias, racial discrimination that happen a lot in this as well, which I think I would just stop here.
Yeah. So Felix, do you work that into your class, your graduate, undergraduate teaching? These issues of bias?
Yes. By the way, I'm teaching the ethics in the technology age. That's one of my primary teaching. Initially was ABET. Some of you probably heard about ABET, that they require us to teach this course. And then our faculty became so interesting, And when the student, when they look at the real example, what Facebook, Google are doing, they're just fascinating about how this industry. So we kind of joke about this is we give all the computer science major this course, let them feel a little bit guilty before they join those companies.
Good, thank you. Okay, so I have a question. Kathy, this is targeted to you. So Taipei City is developing a digital twin for cities, which perhaps you could say a sentence about. But I understand there's a full city traffic simulation perhaps being developed. Could you comment on the utility of that in your work or in the project?
I'm actually not familiar with this project. Maybe Fang Peng would know a bit more.
Fang Peng, can you tell us about the digital twin for cities and the full city traffic simulation?
Yeah, I think we just got visitors from Taipei city government, and they actually try to integrate all sorts of IoT deployed in the entire city. And so they like to duplicate a kind of a virtual city in the virtual world, in the computers, and so they can do simulations. So what I really ask for this question for Kathy is how to scale. I mean, because they are really thinking, they have a lot of observational data for traffic, and they like to do the whole entire cities. So the question is how to scale up.
Okay, thank you for clarifying that. So yes, that question came from Fang Peng. So yes.
Okay.
Yeah, and what's the challenge? What's the challenge or kind of resources they require? And I know AOT actually you have to invest a lot of money in order to deploy collect the proper information in order to achieve some policy goal. So what I'm really thinking is what kind of resources that should we prepare, and what kind of technology we should develop
for the decision-making side of this.
For the decision-making side.
Yeah. So here, this question gets me really excited. Here is where we need so much in terms of algorithmic development, which these are really hard problems, and they are active research. So I don't know if that's good news or bad news for Taipei City. Certainly there are certainly this is exactly the direction that we would like to head into. We currently work with simulators that are completely made up. I mean, the dynamics are real, but there's no city that we're trying to model. It's always some fake grid network city, like a faux Manhattan. So this is really exciting to be able to make some decisions and work with some experts that can actually give us feedback on, okay, the decisions that we're making, do they make sense? Right now, we don't really have any feedback for a fake city. So I think that is really exciting. Yeah, so in terms of what to prepare, I mean, your organization has a lot of compute, so I wouldn't be too concerned there. I think there are a few challenges that I think are very interesting open challenges. One is what I've been calling interoperability, and this is perhaps more used when talking about operating systems than cities. So, for instance, in our project on controlling traffic lights, one question that may come up in the future is when you have a system that you can deploy that controls traffic lights, and you also have the existing system, you probably would like to be able to switch between the two. For instance, if the new system, it's still being tested, still being vetted, it's not 100% there, it may have some failure modes. How can you understand when this will fail, and how can you determine the policies under which the current operators would be able to actually pull the plug, so to say, and switch between these systems? How do you interoperate between the old and the new systems? And this may be really this may be less straightforward than just like figuring out, okay, well, it's not working, so let me switch, because this new system may actually bring the system into a different state that the old system never was in. So for instance, like maybe traffic is going faster than ever before. And the old system, you cannot just sort of switch between them. So I think that's one question that I think will be really interesting moving forward. Another question is, all of this data was collected with some old policy, with some old set of decisions. And so moving forward, if you still want to use this data well, we need to have a good understanding as to, what of that information still transfers into the future, even after you've made a change. So for instance, you add a road a brand new road into your road network. Like your old data, it still has some validity, but you have to think very carefully and determine, what of that data is still useful when your city is essentially a little bit different. Yeah, so for every decision, that's the case.
Right. Thank you, Kathy. No, that's terrific. Fang Peng, I believe we are out of time based on the allotted time that you had given us.
Yeah, we have one more. We can have one more question.
Do we have a question from the audience, from the panelists themselves?
I can just pipe in on that last question with 2 points. One is, Fang Peng, Ethan Tu's work, and he's been doing quite a bit of really good things with just the CCTV cameras looking at traffic density. And the other is a group at Academia Sinica that's done special purpose AI hardware in cameras for traffic. And, this kind of Array of Things and SAGE project with general programmable systems, which you don't really need for this, just for traffic. And so, these lower cost specialized AI chips in the cameras that folks like Academia Sinica are putting together are probably the best way to do the kind of data collection that you need to do the digital twin.
Thank you. That's useful. Thank you, Charles. So, Beth, I think our time is up. And thank you for everyone for your energy and time and for staying so late, in particular in East Coast. And so I'd like to thank you again. And I think we got around 100 participants, others from YouTube. So I'd like to thank you. I think this is very successful, and I think we'll keep in touch. And so I'll call this the end of the workshop. Thanks again, and take care.
Thank you, Bob, for the great organization.
Thank you. Thank you, Peter, Jose, and Pat. Bye-bye.
Thank you.
Thank you.